In this lecture, I am going to show you a simple example that is going to let you practice a few of the things we have talked about in the last few lectures. And we're going to try and swap array data. Okay, here we have two arrays, R0 and R1, and we have numbers inside, 1 through 5 and 6 through 10, and they are arrays of integers. These are two innocent arrays, and we are printing them out. Okay, these two loops are going to respectively print R0 and R1, and we're going to see the elements on the console. But what if we want to swap these two arrays? We want for the elements that we have in R1 to show up in R0, and also have the elements in R0 move into R1. We want to swap the elements between these two arrays, and the elements are going to be swapped in respective positions. So we are basically going to be swapping 1 and 6, 2 and 7, 3 and 8, 4 and 9, and 5 and 10 here, and they are going to be showing up in different arrays. That's what we want to do. One approach one might want to follow is to loop around and copy the elements manually. So we can do something like this. Set up a temporary array that we're going to use to swap these two things. We can take R1 and move that into temp, so we can loop around and move the elements in their respective positions in temp here. So after we move the elements, we're going to have a situation like this. 1 through 5 is going to show up in temp, but notice that we just did copies. We didn't move the elements. So the data is still available in R1. This is just how computers work. After we do that, we can take R0 and move that into R1. We can do something like this. And after this operation is done, we're going to have a situation like this. We're going to have 6 through 10 show up in R1. After that, we're going to take whatever we have in temp and move that in R0. And we're going to end up with our data completely swapped. And we can throw away this temp array. We're no longer using it by now. The data has been swapped. The data that we had in R0 is now in R1, and the data that we had in R1 is now showing up in R0. Okay, that's the flow you can follow to really swap these things. And this is how you can do it in code. It's really simple. We're going to set up our temporary array. It's going to be the same size as the other arrays. We're going to move the data from R1 into temp. What we're going to do is loop around, moving each element at each index from R1 to temp. And after this is done, the data we had in R1 is going to show up in temp. We're then going to move data from R0 to R1 because R1 now is free to take the data because we have a backup copy in temp. So we're going to move the data from R0 to R1. And after we do that, we can take the data from temp and throw that back into R0, and our data is going to be swapped. And if we print again, we're going to see that the data has been swapped. This is going to work. There's no problem with this, except that we are really doing a lot of loops to do something as simple as swapping data. The other problem is that the amount of work we do is going to increase with the number of elements that we have in our arrays. So for example, if our arrays have 10,000 elements, we're going to be looping around that amount of times to just swap data, and that's just too wasteful. We have learned about pointers and the relationship between arrays and pointers, and we can use that to simplify these kinds of operations. Okay, here is another slide showing the kinds of problems we could have with our approach here of looping around and copying data as we go. It is too much looping around. We are copying a lot of data, and it doesn't really scale well. If we have too much data that we are trying to copy, we're going to loop many times, and that's not good. But because we know that the array name is just a pointer to the first element of the array, what if we swapped those two array names for pointers? We know that a pointer is just going to take a few bytes in memory. So what if we just took the pointers that are really the array names and swap them and just go through them to access the data in the array? I don't know if this is making any sense. What we can do is go from two arrays like this, R1 and R0. We could set up an integer pointer in the middle, which is going to act as our intermediary storage. It is an int pointer, and we might be tempted to take R1 and store that in temp, just like this. And then we try and take R0 and assign that to R1. You might think that this is going to work, and keep moving on. And after you have R0 assigned to R1, you might take temp and move that into R0 and think that you have swapped up those things. But this is how we can do that in code. We have our temporary pointer. We're going to take R1 and assign that to temp. That's going to work. But if we try and take R0 and assign that to ARR1 like this is going to be a compiler error because we can't make an array name point somewhere else. And that's exactly what we are doing here. And we're going to get a compiler error. So this is not going to work. What we can do, however, is set up pointers that really represent our array. We can do something like this. Set up PR1 to point to R1 and set up PR0 to point to R0 and then swap these two pointers. This is going to work. So if we do something like this, we have our array, we have the 2 pointers set up. PR0 is going to point to R0, PR1 is going to point to R1, and then we're going to swap these 2 pointers. We set up our temporary pointer, we take PR1 and store that in temp, we take PR0 and store that in PR1, and then we take whatever we have in temp and put that back into PR0. And then we're going to have the 2 addresses that we have stored in pointers swiped out. Okay, this is going to work. And then we can go through our pointers to access the data, and this is going to really swap the data. If you print data like this, notice that we are going through the pointers here. We are not going through the array names because we can't swap them up. That's something out of our control. If we try to do that, we're going to get a compiler error. But we can go through these pointers that we just set up, and we can use the angle brackets notation, and it is going to work. This is the magic we can do because we know about the relationship between pointers and arrays, and it is going to work. The beauty about this is that it's going to solve all the problems that we had with looping around and trying to do things inside the loops like we did before. We don't have to do any loops. And another strong benefit is that this operation here is not going to change regardless of how many elements you have in those arrays, because all we really are doing here is copying pointers. So it doesn't really matter if you have 10,000 elements in these arrays. All that matters is that you are copying pointers, and that's going to be very cheap. I really want you to understand this. Now that you understand this, we're going to go to Visual Studio Code and actually try this out. Okay, here we are in our working folder. We are going to grab our template files like we always do. We're going to copy them into our current project, which is swapping array data demo. That's what we are doing here. And we're going to open this in Visual Studio Code. We are going to go down and put in our code, and this is exactly what we have seen in the slides. We have 2 arrays, and we want to just print them out. We're going to loop and print R0 and loop and print the array 1. And we're going to see the data printed out. Let's try this pretty quick. We're going to bring up a terminal that we can use to play with these things. And we are going to build with GCC like we always do. The build is going to be good. So let's clear and run Rooster. And we're going to see the elements printed out 1 through 5, 6 through 10 from the array 0 and the array 1. Now we want to swap these 2 things. One way we can do this is through the loops that we did, and that's really the hard way. So I am going to go down and put in the code so that you can see this. I don't really need to type this out because it's going to just waste time. You can look at this and type this if you want. So what we do is set up a temporary array, and notice that it has the same size as the arrays that we are trying to swap. If we want, we can even plug in the size here to be super explicit about this. So the first thing we're going to do is move R1 into our temporary storage location here, and we're going to loop around, moving each element from R1 to the temp array. We are going to move data from array 0 to array 1, and we are going to do exactly the same thing. We're going to loop around, moving each element from array 0 to array 1. And after that, we're going to move data from the temporary storage location to array 0, and we're going to loop around, moving each element from the temporary array to array 0. If we do this and try to print the arrays again, we're going to see that the data has been swapped. So I am going to copy the code I used to print these arrays out and reuse that and prove that the data has actually been swapped. So we're going to put that down here and print array 0 and array 1. And we're going to build this again with GCC. The build is going to be good, and we can clear and run Rooster. You see that array 0, 1 through 5, array 1, 0 through 10. And after we swap, array 0 is 6 through 10, and array 1 is 1 through 5. We have swapped the data successfully, but at which cost? We had to loop around many times. You see that we have 3 loops here. And if we have arrays that are really huge, think about arrays with sizes up to 10,000 or 100,000. That's possible. You're going to really loop a lot of times, and that's going to waste a lot of CPU resources, and that's not good. Now, we know that arrays are really like pointers to the first element of the array. So one might want to try and swap arrays out. And the way you might try to do that is say int pointer and say temp, for example. Okay, this is an int pointer. We can initialize this with null pointer, no big deal. This is actually something I recommend to do because uninitialized pointers can be really bad. We're going to learn about this a little later in the chapter. Now that you have this, you might want to swap data through this temp variable here. We know that we can say temp equals R1. So R1 is going to be stored in temp. This is going to be Lego C++ code, and the compiler is going to take it. You see that Visual Studio Code is even happy about this. But if we try to take R0 and store that into R1, we're going to have problems. We're going to say R0 here. So we're taking R0 and trying to store that into R1. We're going to get a compiler error because we can't assign something to an array name. An array name should never change, and if you try to make it point somewhere else, you're going to get a compiler error. So this is not going to work. So we're going to stop here. This idea is bad, so we're going to not even go through with it. What we're going to do instead is set up pointers through which we can swap data. And we're going to do something like this. We're going to set up int pointer, and we're going to say PR1. It's going to be a pointer that is going to point to the array 1 that we have. So we're going to give it R1 as an initializer. We can do that. And we're going to set up another pointer, PR2. And we're going to initialize this with array 2. This is going to work. Let's put in our semicolons. And we're going to set up our temp variable that we had in our failed attempt here. And we can go through these pointers and swap things out. Let's align these things properly. So what we can do is go down here and say temp equals PR1. This is going to work because it's just a pointer that we are assigning to temp. And we are going to say PR1 equals PR0. Because we have a backup of PR1 stored in temp, we can really store anything into PR1 now, and we're not going to lose any data. Okay, I see I messed up things here. This is PR0, it's not PR1. So let's fix this a little bit. And here we're going to be okay if we do something like this. So now we have PR0 stored into PR1. We can simply take what we have in temp and store that into PR0, and we're going to swap our data like this. So we're going to say PR0 equals temp, and this is going to swap our pointers. You have to notice that now that the pointers have been swapped, we have to go through the pointers to print our data. So what I'm going to do here is move my declaration of these pointers to the top so that we can go through them to print for the first time here. So I'm going to put them down here, and I am going to print through these pointers. And the way we can do that, we can even use angle brackets with them. So we're going to say PR1 for the array 1. This is not array 1, it's array 0. So let's say that. And we're going to say PR1 here to print the array number 1. And if we go down and use the same mechanism to print stuff, so we're going to go through PR0 here instead. And down here, we're going to go through PR1. Let's do that. We're going to put a P and an underscore in front. This is going to fix things up. And we are swapping pointers here. And let's try this out and see that our data has actually been swapped. We can build with GCC like we always do. You see that the build is good, and we can clear this and run Rooster, and you see that our data has actually been swapped, and we didn't have to loop this many times because this is really ugly. It is wasteful. You don't want to do this. By just swapping pointers like this, we can really do the same amount of work regardless of how many elements we have in here. If we had 100,000 elements in these arrays, we would just swap pointers, and this would take the same amount of time it takes to swap arrays of 10 elements like we have here. And this is really cool. And this is working because we know the relationship between pointers and arrays. We are taking our array and storing that into a pointer and using these pointers to swap things out. And we have to remember to use these pointers to print stuff out or access the data we have in the arrays. And this is going to make things much more flexible to work with. This is really all I had to share in this lecture. I hope you found this insightful. We're going to stop here in this lecture. The next one, we're going to start and learn about pointer arithmetic. Another series of cool things we can do because we know about the relationship between arrays and pointers. Go ahead and finish up here and meet me there.